everyone, my name is Georgia, and today in this webinar we're going to make an introduction to Azure Machine Learning, and we are going to learn how to build a recommendation engine with a few simple steps. First, let's see what we're going to see today. We're going to see what is machine learning for those of you who don't know it. We're going to see some Azure Machine Learning algorithms. We are going to see the types of recommenders. Recommender is the thing we are going to create today. We're going to create a recommendation model, and then we're going to publish it as a service so it can be used as an API from third-party tools and applications. So, machine learning is part of artificial intelligence. Artificial intelligence, or AI, is technology that emulates human behavior and human performance. It does that by doing three things: learning, coming to its own conclusions, and understanding complex content. It can engage in natural dialogues, and it can enhance human cognitive performance. It helps humans to perform simple execution of tasks. So, artificial intelligence, or AI, is any technique that enables a machine to act like a human. That entails machine learning, which is a subset of AI techniques which use statistics to enable a machine to improve and learn by experience. And a subset of machine learning is deep learning. This is where machine learning learns by its own, by creating multi-layer neural networks. What we're going to do today is see machine learning and create recommendations based on statistic methods. Generally, cognitive services and other AI services have pre-built machine learning models. For example, sentiment analysis. To use sentiment analysis, we use the Azure Cognitive Services by hitting the API, by giving it some parameters, and then the pre-trained model returns us a result. We can do that for speech, language, knowledge, search, and vision. However, those models are pre-trained. That means that someone has trained them for us. Machine learning is the process where a machine learns to create. For example, we use the data like a face, not a face, and create an algorithm or a function or a model using all this data to teach a machine to distinguish between those properties. Today we're going to see Azure Machine Learning Studio. Azure Machine Learning Studio is a fully managed cloud service that helps you easily build and deploy and share those models, and also create predictive analytics solutions on them. Generally, to use Azure Machine Learning, you need one of those. You can enter and have an 8-hour trial without signing, just for a quick evaluation. If you have a Microsoft account or an Office 365 account, you can log in and have a free workspace. This access will never expire. However, you have only 10 GB of storage, but it supports R and Python and predictive web services. If you need it for production purposes or enterprise purposes, there is also the enterprise grade that has some additional features. For now, I think the free workspace works fine for us. So, if you follow along in this tutorial, you can choose the most popular, which is the free workspace, use your Microsoft account and log in. What is machine learning and what are machine learning algorithms? The most common are those three. The first is called classification. Classification distinguishes and can realize if we have some properties, if and we provide a third property, it can distinguish if this property is type A or type B. Regression is used with quantitative data, and we can distinguish how much, how many. For example, we can provide the algorithm with past data, for example, the weather of the previous days or the previous years, and it can predict the weather temperature for tomorrow. Clustering. This is similar to classification, however, it doesn't just distinguish if it's A or B, but depending on the data we feed it, it organizes into groups, the so-called clusters. So this is called clustering. These are the most popular machine learning algorithms. Of course, there are many more, but these are the basic things you need to know before you start. So as we said, classification, you can map a function from the input to discrete variables, three groups. In regression, you need predictive modeling that approximates a mapping to a continuous output variable, for example, from all those years to Tuesday. And how this is organized is the process of grouping similar things, similar properties. So, how do you build your own machine learning model? The first step is to prepare your data, because machine learning relies on statistical analysis. So, the basis of everything is data. You need to have enough data to train and teach your model. Once you have enough data, you might need to do some modifications, whether that's cleaning empty values, whether that's cleaning duplicate values, everything you can to help your model, depending of course on the algorithm you are going to use, to be more efficient. Because when you have data that are not appropriate or have very extreme values, your model will not be as efficient or accurate. So the first step is always to prepare your data. Then you create your model based on those data. You build and train it. And the last step is you run this model. So, let's see. How do you create a recommendation service? There are many approaches to doing this. First is the rating. So, you take some average of population like IMDb, and then you choose if the rating is higher than a number, recommend it, or don't recommend it. This is by taking the average from multiple movies, let's say. The second one is content-based filtering. For example, I see that you love superhero movies. So, if Iron Man is a superhero movie, recommend it to the user. And then there's the collaborative filtering, which is what we're going to use. For example, there's someone that has the same opinion or the same taste like another one on an issue. So, if this person likes something, it's more likely that the other person will like it as well. For example, if Gal and Caesar have both liked Heat, Mission Impossible, and The Terminator, then since Caesar also liked Casino Royale and Gal is looking for a movie to watch, then it's safe to say that maybe because they have the same taste in movies, Gal will also like Casino Royale. In this exercise today, we're going to use the Matchbox recommender. The Matchbox recommender combines the two previous techniques we have seen, content-based and collaborative filtering. It is a hybrid recommender, so it usually produces more accurate results. So, this is the model we are aiming to build today. We're going to take some data, create a recommendation, and score this recommendation. we will have three datasets. The first dataset is the ratings. The trained Matchbox recommender uses a dataset of user item rating triples and optionally some user and item features. So we're going to have one dataset that is called ratings, which has the user ID, the coffee house ID the user has rated, and their rating. Then we're going to have some coffee house feature data. For example, one coffee house, besides the location, might have a specific dress code, specific accessibility, price, ambience. Maybe it has Wi-Fi or it doesn't. It has a smoking area or it doesn't. So we'll combine this data along with the customer feature data, because every user, besides the location they're living in, also has some preferences. Maybe they are a smoker, they have a different drink level, or a dress preference. They like to use transport, or they don't, they have a different personality. So, based on some user ratings, we're going to use the customer feature data and the coffee house feature data to create a recommendation to the user on which coffee house they should visit next. So let's proceed to the demo. We're going to go to the studio.azureml.net to take a quick tour of the tool. If you want to experiment yourself, I have uploaded these datasets to this address. Otherwise, let's continue. Okay, let's open the browser here. This is the Azure Machine Learning Studio. It's a web application. It's a cloud service from Microsoft. So once you sign in with your Microsoft account, this is the page you're going to see. Here on the right, we can see we have a workspace. If you have some experiments, you can see the latest here. If you click here, you can be taken to the Cortana Intelligence, and you'll be taken to the homepage of the Cortana Intelligence suite. The Cortana Intelligence is a fully managed big data and advanced analytics suite to transform your data into action. If you want to use it, you can go there. Otherwise, you can go to the gallery. This is the Azure AI gallery. Let's click and see what we have here. The Azure AI gallery is a place where you can find experiments, solutions created by others, components, so you can use them in either Cortana Intelligence, in Azure Machine Learning, and you can even publish your experiment to the Azure AI gallery. So it's interesting to see what other people have built and how you can build on that. We don't want that. We want to go to the Azure Machine Learning Studio. Here you can see some resources, some announcements. You can find it, but enough so far. Let's get to the Azure Machine Learning Studio. Let's wait a bit till it loads. Projects. Let's go to the top. Projects are a collection of experiments, datasets or notebooks, and other resources we have created, representing a single project. Once we have created some experiments, we can group all those resources together. Let's see an example. We can create an empty project. You can enter a description if you want or not. We click the ticks button. We wait a little bit and it creates a project. Once we create a project, you can add assets. If you have some assets, you can choose from datasets you have created, experiments you have created, modules, notebook, etc. You can do that after you have finished experimenting and creating your web services or everything. What a project does is group together similar resources. So okay, let's close the screen. We're not going to use it right now. So let's go to the second tab, Experiments. Here you can find all the experiments that you have created and run or saved as drafts. When you click on an experiment, you can see like a mini preview of it. By clicking the new button, you can create a new experiment. You can create a blank experiment or choose from numerous Microsoft template experiments. You can also use them as a base to build your own application and machine learning model on. So if you're relatively new and you don't know much about data science or algorithms or neural networks, don't worry, you can start reading up upon them and see ready examples of how you can build everything you need. Okay, let's close this. Then we can go to the web services. Web services are the experiments and models you have built and published as an experiment. Published experiments you can use to expose as an API to use from your application. So we have built a model, we have trained it, it's ready, then we use a web service, a predictive experiment, to get results. We'll see it in action a little bit later, so be patient. Here, on the next tab called Notebooks, I don't have currently any notebooks, but here you can see all the Jupyter notebooks that you have created. In the next tab are datasets. Here you can upload your own datasets. Azure Machine Learning has a lot of already prepared datasets for you if you just want to experiment. And I'm sure you can find online more others or create random samples to play with. Here I have uploaded the ones we're going to use today, which is the coffee house rating, the coffee house feature data, and the customer data. Let's see what options do we have to upload new datasets. We click on the new button and then we can upload a dataset. We can choose from a local file, we enter a name. These are the types we can upload. Could be a generic CSV file, text, light file, zip file, R file, etc. We can upload new version of an existing dataset, and we can add a name and description. Okay, I'm going to close it since I don't need it anymore. Here we can find all the trained models we have created. These are previous experiments I have done on the recommendation service. And finally, on the tab settings is a collection of settings. You can configure your account and resources. For example, how much storage do you have, some keys, some tokens, the users you have that have access to the workspace, etc. You can invite more users by clicking this button on the bottom. So, now that we have seen a small tour of the Azure Machine Learning Studio, it's time to start an experiment. I have uploaded my datasets here. If you are starting an experiment and you want to use your own datasets, upload them from here. Otherwise, you can use the datasets provided by Azure Machine Learning Studio so you can start playing with. We're going to create a new experiment. It's going to be a blank experiment. Okay, this is the experiment page. Here on the left, we can see all the items or modules we can drag and drop into this area here. This area here is our experiment canvas. All those on the left are called modules. Modules are used to do certain things. Could be algorithms, could be statistical functions, could be the datasets, other trained models, anything. On the right, we have the properties window. The properties window shows the properties of anything we click on in our workspace area here in the middle. Currently, we don't have anything on our experiments on our workspace area, so the properties is on the whole project. The status is draft. We can provide a summary for the project, for the experiments, a description, sometimes there's quick help if needed. On the bottom we have this bar which helps us save our experiment, save it as a different experiment, so we can use it to make a duplicate, for example. This button is used to run the experiment, or if we haven't finished, run up to the point we have built. And this is what we use after we have finished to set up our web service. So let's start building. Since I have already uploaded my datasets, I will go to Save Datasets on the left and choose My Datasets. And I can drag and drop my modules in here. So first we have the coffee house customer data, house feature data, and the coffee house ratings. So to make things a little bit more tidy, I'm going to put it in this order, and you'll see later why. So I have dragged and dropped my datasets. As I said before, Azure Machine Learning Studio has multiple datasets ready as samples, which we can see a lot. There's breast cancer info, there's flight delay data, there's the IMDb movie titles. So if we want just to experiment and play with Azure Machine Learning Studio as we learn, you don't have to find new datasets or create your own. You can just come here and use one of those. So I have dragged and dropped my datasets here. As you can see, as soon as I drag a module on the area here, and I click on it, I can see the properties. By right-clicking on it, I can delete it, copy it, paste it, and I can see and visualize this dataset. So let's go ahead and click Visualize. By clicking Visualize, we can see the data this dataset has. So we can see that this dataset has 1,161 rows and 3 columns. And we have a user ID, the place ID, and the rating they have given it. We can see some statistics on those and some rating with comparison to a histogram, place ID, and some data to give us an example. It's a good practice when we have ratings that we don't have more than 100 distinct values. This is a recommendation. So our model will be more efficient. So let's go ahead and see the other datasets. This is the coffee house customer data. This is the data that characterizes each customer from the first rating. Let's visualize. Here we're going to see that we have multiple options, which is the user ID, of course, latitude, longitude, smoker, drink level, dress preference, which is formal, informal, no preference, ambience, family, friends, etc. Some interests maybe the religion is important, or the activity if it's a student, it's a professional, weight, budgets. All of these features characterize the customer, the user. And then we have the same feature data about the coffee house. Let's visualize this dataset as well. So we have place ID, latitude, longitude, name, address, city, and several other characteristics of the coffee house. So what we're going to do is create a recommendation service that uses the ratings of previous users, and by taking into account the user characteristics and the coffee house characteristics to recommend a place to a new user. Okay, let's start. Generally, when we're creating a model, what we do is we have an initial data set that has the initial ratings. We want to split this data into a training data and test data. What that means is, since we have some records, we're going to train the model using some of them and test the model we have just trained with the rest of them to see if it's accurate or if we need to do some adjustments. For this reason, there's the split data function. The split data function is in the data transformation category. If you can't find it, you could just search in the search bar for it, as I did right here, and drag and drop it inside the workspace. As you can see, under each module, we have a little dot. That dot connects each module to the other. Each module, depending on its function, it has either an input and output or outputs. The dataset modules do not have inputs. Since they are the input, they have also output. So we connect the coffee house ratings by clicking on the dot and releasing the arrow once it hits the input dot in the split data module. Let's click on the split data module. The split data module, here on the right, we can see what we want to do. We want to split rows? No, we want to do a recommender split, since what we're building is a recommendation service. Here it has some fractions. We're going to leave it default. So this is it's going to take half of the data for training and 25% for testing. Usually this is used by 0.80 and 0.20, but this is not mandatory, and if you want the science behind it, there's a whole process of how do we split data according to our experiment. So today we're not going to focus on this part. We're going to use the default recommender split and move on. So now we have built some modules. We haven't named our experiment. Let's name our experiment. We do that by clicking on the experiment text on the top and start writing. So I'm gonna name it Introduction to Azure. And then, as soon as we have started building it, we can save by clicking the Save button, so we don't lose any changes. So let's try to run this experiment and see what happens. We click on the Run button on the bottom. So we're seeing that it finished running, it split the data, but it has nothing to do with anything else. Since the modules we have added before were not connected to anything, they disappeared. So we're going to go ahead and add them again. So it was the customer data, if I'm not, and the feature data. We see a tick here, that it means that our model has run up to this point. So we have split the data into training data and test data. We're going to choose some columns from the rest data to use in our train Matchbox recommender. But before we do that, we're going to add a train Matchbox recommender, which is the algorithm we're going to use to train our model. So we're going to bring in the train Matchbox recommender module. As we can see, it takes 3 inputs and has 1 output. It has the training dataset of user item rating triples, the training dataset of user item features, and the training dataset of item features. So the user item features are these, the user characteristics, and the item features is the coffee house characteristics. So since we have split our data, we can go ahead and this is the results dataset 1, the result dataset 2. If we want, we can visualize the split datasets and see how many values one has and the other has. We can see that we had more than 1000 rows. It has now split it in about half. So let's go ahead and connect the first dataset to the training dataset. Then we have several data here that we don't need. We have so many values that we don't need. We're going to need properties that match certain characteristics. What we're going to do here is use the select columns module. Nothing difficult. All the select module does is select some columns from the dataset. Let me just bring them in and I'll show you what I mean. So for example, I have this dataset, let's visualize, that has 11, 12, 19 columns. If I want only to use some of them, I would use a select columns dataset. As soon as I click on it, I see that the properties windows changed and I have the option to select a column selector. So let's launch the column selector. Here I can see all the columns I can select from the complete dataset. I'm going to use the user, of course, latitude and longitude, since when recommending a place, distance is important because I can't recommend some coffee houses in another country. It's illogical. So I will choose interests and personality and budget. There is no default way of doing it, and there's not definite way to do this. And the more you use doesn't mean that the more accurate your model will be. Depends on your data, it depends on your recommender and what you're trying to build, and it depends on the context. For example, people of similar personality might go to the same coffee house or restaurant. People of the same weight might not. So maybe some characteristics we have do not match exactly what we need. So the best course of action here is to choose some, train our model, see the results, and there start adding upon it. So I'm going to use those 1, 2, 3, 4, 5, 6. And I'm going to go do the same in the coffee house. It's important that we have similar. For example, I chose 6. I will choose 6 here as well. So let's go here. Of course, I want the place ID and the latitude, longitude. And from the rest of the properties, for now, I am going to use the price, the, let's say, dress code, and that's it for now. So I click on OK, and I have selected those columns. Then I can go ahead and connect the results to this, to my train Matchbox recommender. If we need, for example, if my data have empty values or my data have duplicate values, for example, in the initial ratings, let's open the dataset and see. you can't have duplicates. So the same user should not rate the same place twice. All values should be unique. One user, one place, one rating. So my data are I have prepared my data before uploading it to the service. If I didn't, there are several modules of data transformation. For example, to remove duplicates, you can remove duplicate rows and do several manipulations on your data before you feed them into your recommender module or your algorithm if you have a different algorithm here. Let's try and run this and see how it goes. So I have the little clocks, they're processing my data. So I see a lot of green ticks, so I guess that everything runs fine, no errors, no values missing, no nothing. And I have trained my Matchbox recommender. Here we can set the number of trades, number of recommendations the engine will provide for us. And we can run this in batches. This has something to do with the algorithm and how many iterations it does to yield the results. So how do we see the results? We have to score the Matchbox recommender and see the scores it gives to our training and taste data. I am going to search for the score Matchbox recommender. As we can see, the score Matchbox recommender has multiple inputs. The first thing is the trained Matchbox recommender, which is this, our model. We have the dataset, we have fed it into an algorithm, we have a model. So to score this model, we have to add it here. So this is the trained recommender. As you can see here, if you click on it, you can delete the connection. Once you open a connection, it evaluates and sees which dots you can use. So since I have a model and a trained model, the module doesn't accept this in those inputs, but it only lets you put it in the first input. It's the trained model. The second input is the dataset to score. Which is the dataset to score? It's our test dataset. Where we're going to get that? This is the second dataset we took from the split data function. So let's take this and put it here. Okay, the third is the user features. The user features, we can find it from here, which is the customer data. And the item features is the coffee house characteristics. So we take this here. And then we can do an evaluation. So we use the evaluate recommender module. We're going to drag and drop this here. Let me just do some rearranging so everything fits nicely. So here we're going to take the test dataset we had from the split data. As we said, the first is the training dataset and the second is the test dataset. And we're going to get the results. Okay, let's run our model. We're pushing run. Hopefully it won't take as long. If we have made a mistake and there's a connection missing, there's something going wrong, instead of the red tick, we're going to go red X, and we're going to get the error message from the exception. And usually along with the exception, you'll have a code that you can find on the documentation what it means and how to fix it. So it's really very helpful. So we have run our model. I forgot to set the properties though for the score matchbox recommender. So if we push on the score matchbox recommender, we're going to use the default. We're going to use the item recommendation, the recommended item from rated items. I could use it from all items or from our unrated items to suggest new items to user. But since I have a test, training and taste data, I'm going to use from rated items. The maximum number of items to recommend are 5, and the minimum, because the algorithm might not find 5, will be 2. Okay, let's see the score dataset. We right click on the dataset, we click visualize. So here we can see the user from our test dataset is only 69 users. And from those 69 users, we can see which coffee house ID the recommender chose for us. So we have 5 recommendations for each user, from the most suitable to the less suitable. You can see that some are missing, since it couldn't find 5 to recommend, so it recommended less, but the maximum is 5. So that's it actually. We have built a very simple recommender based on the train matchbox recommender, which uses collaborative filtering. It takes into account the characteristics of the user and the characteristics of the place, combines them, and based on the rating of previous users of same characteristics, gives you results. If you want, those values can be more user-friendly, and instead of the user, you can use the select columns to join and do data manipulations to return more readable results. But if this is going to be used from an application, let's say, maybe returning an ID is more efficient. It's completely up to you. So, great, we have prepared our data, we have created the model, we have built and trained it, and we are ready. So the next logical step is to set up a web service or a predictive experiment. So let's go to this tab on the bottom and set up a predictive web service. We click on this. There's a lot of some animation going on here. We can see that it's building our model. It starts doing some things. So it finished. Then we have the predictive experiment. So this is our training experiment. Here we can go back as many times as we want. We can twist things around. We can add more data, remove data, try different columns, type different characteristics, maybe different algorithms, do anything we want. And as soon as we were done again, we can retrain the web service and update our predictive experiment. I don't know if you can see all the way to the bottom, but the first tab says update predictive experiment and the second says retrain web service. Let's go to our predictive experiment. So if we see the modules side by side, what it did is it trained and created a model, a trained model, and we have those new things here, this new module like, which is the web service input and the web service output. So if we go back here, okay, let's save the experiment. Back. What the scorer does is get a trained model and use a dataset to score by using the user features we have provided and the item features we have provided. A predictive experiment does the exact same thing, only now the dataset to score is no longer our dataset, but a web service input. And we're going to use user ID. And the output is the output of the recommender would be the recommendation, would be the web service output. So we're going to call it output. Let's call it web service output. Okay, let's save it. Everything, any change we do, we must run it. It's running. I see everything is green, so we can now go ahead and deploy this web service. Click on deploy, and it starts deploying the web service. So now we're taking to a different dashboard, the web service dashboard, and I see that here it gives us an API key, an API help page to test this web service. What it did, it took our model, our pre-trained model, and it uploaded it as a web service. Now we can use our web service from our application or from the web to test this theory. So let's test. So we can use to enter data to predict. This is not right. Let's go back. Let's go back to experiment and make some corrections. Oh, I left completely. Let's go here. Let's remove this connection because we don't really need it. Let's deploy again. Okay, every time we make a change or move something around in the dataset, we have to run it again, as we said before. As soon as we run it, we can deploy it again. Wait for it to finish. Yes, it has a warning if we want to override our model. So let's go to this dashboard. We can test the experiment by using a request or response. Now I have to go through my data and find a customer. Let's see the customer data. And provide some values. Okay, let's take by chance. I'm not going to enter any more data. Let's see the details. We can see here the results, but we can't read it here, so let's go to the new web service experience. This is the dashboard. Let's wait until it loads. Here we can manage and monitor this website. You can test the endpoint. You can even download the code. So let's open the test endpoint here. So user test request response. Oh, why? Let's use place data. Okay, something seems to be wrong here. Don't worry about it, we'll go back and fix it. Anyhow, this is how you can test your web experiment, what you've built, to see if it's working. It should work similarly to this. So if you go back to your experiments, let's go to the experiment. It should return the same output as here, 5 items as the score Matchbox recommender. And this is the dashboard. You can make frequent response. You can use those web services to test, to monitor. You can retrain your web service via the APIs without needing to go back and retrain your model or your datasets. You can use this endpoint. I think it gives you some keys and even a sample code. So you don't need to write your own code. You can take a sample from here. You can use it from any technology you want. It's a REST API. You can see some analytics, how many batches, how many trainings, how many times it has been hit, tested, and get a Swagger API that you can use as documentation. So this is it for today. We have seen a very brief overview of the Azure Machine Learning. We have built a simple recommender that recommends coffee houses based on the user features and characteristics. Thank you very much for listening. I have a blog. You can find me anywhere on Twitter, in my blog. You can like my page on Facebook. You can see my GitHub. The datasets are uploaded there. If you want to start building the same thing, you can find me on LinkedIn. If you have any questions on today's webinar or anything else, feel free to contact me. I will respond to as many of you as I can. Thank you very much for listening, and until the next time. Goodbye and have a good night.